Cottrell. I'm a Colorado School of Mines mechanical engineering student, and this is my final project for MEGN 200. It's the TrashBot. But before I explain the bot, what's the problem here? So, if you've ever driven down Colfax, you've noticed there's a lot of trash. Sometimes it's in the middle of the road, sometimes it's on the shoulder. Regardless, it's very expensive and dangerous to try and clean up that trash. According to two states that responded to a survey put out by John L. Wright, the author of the paper that this quote is from, it was $10 per mile of highway, $10, and $5,000 for 30 miles of dual highway, which is a lot, especially in urban areas where there's more people, there's more highway, there's more road. And this is from an older paper as well, so it only goes up, it only gets worse. So, what's the solution? TrashBot is an inexpensive, much safer option to keep roads clear of trash and small debris. Instead of being on the road, workers will operate TrashBot remotely from a safe location. This not only improves safety of drivers and workers alike, but also will reduce the impact on traffic flow. TrashBot is designed to fit in even the smallest shoulder sections of a road, making anything from rural to urban areas ideal places to employ it. This is hard work.
Sure.
Oh, it's not. Now that we've seen TrashBot in action, let's get a closer look at how it actually works. So, there we go. Here we are. So you can see this thing that's definitely not falling off at this point because it's been, roughing it outside, and these are prototype materials. This is the grabber claw. It is powered by a blue 9G servo, and it is, is gear operated right there. And they go like that. This is a rack and pinion mechanism. It basically, this gear turns and it moves this in and out. So the claw moves in and out. There we go. Now, to look on the inside of it, there's some important stuff here. First, we got a rechargeable battery. This is a Milwaukee battery. Any Milwaukee rotary tool or the smaller drills will have these smaller circular batteries like that. We've got a fuse in case something goes wrong, because, it's out in the middle of the road. We're going to have some fuses just in case. We've got a power switch right there. And then on the inside, we have an Arduino R4 Wi-Fi that connects to the controller, which I'll grab in a second. This is an H-bridge, the red chip right there. That controls the DC motors on the bottom. There's one of them, and they're pretty powerful so that they can actually carry the weight of the trash. And let me grab the controller real quick. So this is the controller. I know it doesn't look pretty, but this is all prototype. This is proof of concept material, but it is easy to open up and show you what's inside. So we've got another Arduino Uno R4 Wi-Fi. It connects directly to the one that's in the bot itself. We've got two analog sticks, 2 buttons on the top here, and a handy-dandy USB cable in case, or not even in case. This is, you connect it to your computer, and eventually there will be a camera on the bot so that the camera will send a video stream of what the bot sees to the computer while you're controlling it. So you have a very, video game sort of experience. And yeah, that's the controller. In addition to hardware, this robot needs some sort of software to get everything to actually work together. That's where this handy-dandy flowchart comes into play. I'm going to move my camera again so that you can see it. So basically, it's pretty simple. The robot is turned on. It connects to the Wi-Fi via passwords that it sends each other. You know how it was to Arduino R4 Wi-Fis? They can send Wi-Fi to each other. They, I'm pretty sure, don't need an external Wi-Fi source to connect to. This TX or RX is the transmitter or the receiver. The transmitter is the controller. It sends the inputs from the buttons to the receiver, and the receiver is the actual robot. It receives those button inputs and then moves the motors and servos according to those inputs. Pretty simple. Here's some snippets of what makes it work. So this is data joy button state. That is the joystick 1 button. So it's not only just an analog stick, but it's also a button that you can press. This closes the gripper, it goes boop, and then Joy 2 button state, that's the other analog stick. If you press that, it opens. Now these are controlled by servos, so you need to make sure they don't break. So we've got these constrain commands over here that make, this is the arm that's going to be the thing that goes like that, and then this is the gripper. The arm can go from the angle 40 to 200, and the gripper can go to 0 to 40. That seems to work. Here is the circuit diagram for the motor side of things, the robot itself. So it says Arduino Uno R3 here. It's actually an R4 Wi-Fi. You can see these go to the H bridge. There wasn't an actual component for that, so this is what we've got. Motor 1, motor 2, servo motor 1, and servo motor 2. It's controlled by pins A0 and A1. I might have changed it to A5 in the final product because A1 was being funny, but this was what it was supposed to be, so it's fine. D4, 3, 2, and 1, not 1. 2, 3, 4, 5, 6, 7 all go to the H bridge and the motors. The H bridge is what actually controls the motors. This sends data to the H bridge. And these are the references for the earlier parts of the video when I explained the problem. This is the paper that I believe it was John wrote about the expenses and the surveys done for all the states on how much they spend on cleaning up the trash. And this is a website, this is the U.S. Department of Transportation, facts about how many casualties / fatalities occur each year for road incidents involving construction workers, cleanup workers, and the like.